You can go ahead, Millicent.
Okay, cool. Um, Hi everyone. Thank you very, very much for joining us this month for our seminar. We are so excited. Today we are hosting experts from YUX company, which is a Pan-African Research and Design Agency. And the team will be talking about evaluating the cultural relevance of AI models and products, learnings from maternal health ASR, data augmentation, and user testing. I just want to talk to share a little bit about the team. So YUX is a Pan-African research and design company that blends behavioral science, HCI, and machine learning to co-create tech and AI products tailored for African communities. So with a team across Dakar, Abuja, Kigali, Nairobi, and Accra, YUX partners with global and local organizations on projects in healthcare and education, agriculture, and fintech. So this is the whole team, and it's so exciting because this is the first time we're going to have like several speakers on the same seminar call. So we will hear from Ian, Oche, Bashir, Paul. Oh my gosh, you guys have very hard names to pronounce. But yeah, Luchi will be there, Melissa. It's so exciting. Thank you very much for agreeing to give us a talk today. And I'll just hand it over to Ian to share his screen, and then Ian, you can take it over. I've stopped
Thank
sharing.
you. Thank you so, so much. Thanks, Millicent. Thanks, Mushai, for the when we met and all the learnings we already got. And of course, thanks, Stephanie and all the team for putting this together. We are very humbled because we are a very young team. Also because we are not academics and be able to present, some of the concrete solution and things we do to your team and to your partners. For us, it's an immense opportunity. So thanks for that. Happy to just engage the conversation. As you can see, we have many people because we are a lab and we do several things. But everything is centered around the cultural relevance of AI models. And I believe for us, it's just the start of the discussion to make sure we are on the right track. So thanks again for that opportunity. Just wanted to make sure that you can see my screen.
Yes, it's visible.
All right, that sounds good. All right, so this is the team, and sadly, Melissa was not available to join us today. She's conducting some user testings, but we have Elizabeth, who actually is going to present some of our most interesting project who's joined us. But as you mentioned, different people in the team, and if you don't know how to pronounce the name of Dana J, most people call him DJ. He is back in California as a student, but yeah, thanks for making the time, DJ, as well. So we are a mixed team, mostly comprising of machine learning researcher and engineers and social researcher or design researcher, which is the thing we've been doing in the previous year. Kitala is the name of the team that is focused on cultural AI. That we created within the entire organization. It means reflection or mirror, because for us it's very important that we have AI systems that are really tailored to each communities and really reflects who they are and the diversity of the continent. Naturally, our core to our reflection is to find scalable ways, but also ways that are adapted to our context so that we can also give back to the communities and build with them, design with them. And of course, evaluation is a key element in that. So you mentioned a few words on the company, but very briefly, we're mostly focusing on sub-Saharan Africa, even though we've done some project in Egypt. And we work basically with two types of clients. The first one is the big technology companies like Google, Meta, TikTok, Square, and so on, generally on covering Pan-African user research projects. And the second tiers of clients is the big foundation and large NGOs, could be UNICEF, Gates Foundation, Médecins Sans Frontières, or GSMA. And that could be project in health, education, or financial inclusion, and again, generally on different countries. Most of the research that we do is mixed method research, quantitative and qualitative. And we're not only a research firm, we're a design firm. So we take a lot of time and energy to imagine different products, services that are tailored to the communities. We are around a team of 40 people spread across the continent. And I'm based in Dakar, by the way. We didn't say where we are based, but yeah. And so yeah, didn't introduce myself even. But yeah, my name is Jan and I'm based in Dakar. All right. So these are the projects we working on the lab. So as I said, since last year, we started this lab focusing on, the impact of social science on AI overall. We started different initiatives, and today we're only going to focus on presenting 2 of them and some of the other thinking we have around design methods and evaluation methods. The goal of our lab is mostly to help others, building AI tools and to make them relevant for the continent by one, providing data sets, mostly for AI evaluation at the moment, maybe for training later on. And the second angle is building behavioral research, understanding of trust and usage and the user experience of AI system for specific use cases. But we also have a project that we still, putting together right now and doing the analysis around, mental health and the lens with religion and how people may use AI for that purpose. Anyway, what are we going to talk about today? We have a very busy agenda, so I'm going to start very briefly to talk about evaluation framework that we've seen recently emerge that can both touch on the model all the way to the impact evaluation of different products. We're going to introduce LOOKA, which is for us the key way to be able to collect data at scale in the right manner on the continent. Then after, we're going to split the presentation in 2 parts, one on the model evaluation, presenting Nakala and Stereo projects, and the second part will be on product evaluation, sharing 2 projects, one with the Gates Foundation and Dimagi, and another one methodology we use with Google, right? And we want to save some time for opening up for discussion, future work, collaboration, and what's the implication, for us in the field. Sounds good? Feel free to drop your question, by the way, in the chat while, we present those different parts. So first, a quick overview of existing design evaluation framework. So we don't only focus on evaluation because we also incorporate design in all the work that we do. And sometimes a lot of the mistakes that we see at evaluation could be addressed at the design phase. So we believe it was important to take a step back and look at the design process. And obviously, we are good students. We've done our homework and looking at some of your guys' work. That is very interesting, notably this notion of playbook and providing very concrete guidelines on how to build safe models. Not specially designed for the continent, and this maybe where the improvement could be done. And I know you guys mentioned working on a playbook, which is definitely something interesting. Google people did something also similar with a lot of focus on building the trust and the interactions in this pair guidebook, which is again very interesting because it's global. It's global trends, but maybe some of the limitation is that then after, when you are an engineer, how do you actually do? And a lot of these guidebooks or playbooks don't really address the evaluation side of things, like how do I concretely evaluate my model, my product, and on what metrics. Recently, we found amazing work by the agency found that not only imagine a framework, like some of the things that I may present are generally like just a Google slide, right? But here we're talking about a framework that has become a tool, and I really love the fact that these guys put together an entire tool, and the framework is looking at different level, and we've been inspired by that in the thing we're going to present as well, which is the model evaluation, the product evaluation, and then after they break it down into user and impact evaluation. Some other people condense step 2 and 3, but I guess overall is the idea of how can you evaluate an AI system from the model all the way to the impact. And this tool is actually very useful. Some people leverage that as well, focusing on only 3 steps, which is the model assessment, the user journey assessment, and the product assessment, but with a focus on agriculture, where I believe there is a lot of room to adapt our framework for specific domain. I just leave that for you to read, but I think that this one was quite interesting because it deep dives a little bit more into the type of metrics you can build and how you want to build them and how you want to build your evaluation system. ID Insights leverage also the work from the agents you found to create a framework. What is very interesting in this one, I mean, I guess is the notion of A/B testing, which is quite common in the domain of UX and web and human-computer interaction. But what I like is also the idea of using proxy to evaluate the long-term impact. The idea is that evaluating an impact is long and it takes a lot of time, but you need to have an idea of if you are going on the right way before evaluating the impact. That could be through an RCT or other methodology at 6 months or 1 year. And they provide this notion of proxy that is defining different metrics that can tell you if you are on the right track or not. And I really encourage you to read that. So on our side, we're not building a framework, don't worry. We're just very humble and probably thinking that as a toolbox. And this is what we're working on. As you can see here in gray, these are the things that we don't do. So for instance, impact evaluation and long-term evaluation is not something that we specialize on. But everything else, and notably when you see the little blue in italic, are concrete examples of the project we've been working on that are testing or using these methodologies. The key question for us, when we want to improve this toolbox and make it public, of course, is the domain adaptation. Like, we show in the example, like how much we need to customize those specific tools or elements of evaluation and design for health, for agriculture, for education. The second thing is the type of product, because evaluating an AI agent that takes decision on its own versus chatbots is probably different versus, any business solution. And of course, the idea behind would be to go towards, official benchmark and regulation, or maybe incentive, if you don't want to look at the regulation side, that can have people using those evaluation metrics and tools along the way. And we'll come back to that on the conclusion. Right. For today's focus, we focus on those blue box over here, which is, the different benchmark and data set creation around the biases. Another one around the ASR evaluation. And then after we also touch on the product side of things, on red teaming, we did on the chatbot for maternal reproductive health, and diary testing we did for a project with Google, right? Sounds good? All right, then I'll pass it over to Serene, who leads our quantitative spin-off that is called LOOKA. Over to you, Serene.
Great, thank you, Jan. So yeah, to go over a bit about the LOOKA and the tool that we created. So if you go on the next slide, so essentially what we are is we're a research platform, and we're dedicated to bridging the gap between organizations and African consumers. So making sure that the voices of those consumers are heard to the different organizations. So on the next slide, just taking you a bit over to what we're pretty much doing in terms of the tools. So we have mainly two tools. One is survey and panel, so for quantitative research and for qualitative research. And essentially, we created those to be able to allow people to be able to collect insights from those consumers in both quantitative and qualitative manners. So now, especially when it comes to the whole system of evaluation and annotation, we have our data collection tool. And essentially, how this data collection tool, we built in the mindset of being able to do it both for offline and online methodologies, because to be able to reach the full spectrum of consumers, especially on the continent, you have to be taken into account of the different types of perspectives that people are coming from. And essentially with our LOOKA app, which is our own proprietary app, we allow for our network of approved surveyors, but also panel members to be able to help us collect the data on the ground. So it can be done for both in-person interviews, but also participants filling it themselves. And we have different features that allow for both audio, text inputs, so that we can pretty much help a lot with the organizations that we're working for in terms of evaluation and annotating. And of course, we have the app, but it's also available on a web link and available for both phones and computers. So really allow it for the flexibility of the different types of consumers that we're trying to target. Now on the next slide, here are the different use cases. So it can be help, especially for scripted speech and videos. It can be helpful for focus groups and in-depth interviews, also for language text. And we do everything in terms of recruiting the participants, doing the scheduling, what is going to be moderated or unmoderated, but also the payment part of it. And outside of just working, of course, with YUX, but we have been able to work with organizations such as Applause, Qualitas, and AI that do a lot of work within the AI world. Yeah, and then next slide, just to go into deep in terms of how we actually manage our panel. So we have our own, in the software, we have a part that's really focused on just managing the panelists. So getting a sense of the overview of the responses from the different panelists. We also have a WhatsApp group management that allows us to help, within support both technical and also on the context of the project, and allows us to get views of the audience demographics, but also being able to push notification reminders, whether it's going to be something that's only one-off or over a specific time frame. And then on the last part, which is really a very important aspect for us, is payment infrastructure. So as you might know, to be able to reach projects over different countries, being able to pay to those participants can be a hassle, but we have built our own internal payment infrastructure, which allows for not only sending incentives in terms of cash, but also airtime, which is available around 24 countries, which allows for seamless transactions as the participants are going to be completing the different tasks. And of course, we're looking to integrate other features such as like gift cards and bill payments along the road. But yeah, in general, that's essentially how the LOOKA tool works and how we try to help different organizations in terms of the evaluation and annotation.
Fantastic. Thanks, Arina. And we'll come back, on how we use, LOOKA at different step of the way. And, it's always under construction. There are many things we want to improve on the platform as well, but yeah, it's already available online. Cool. Right now, part one, touching on the model evaluation, and I'm conscious of time, so I'm going to go quick on the literature review. We have a lot, and we ground most of the work that we do in a lot of literature review, try to understand the state of the art, and notably what's useful for us to do and what is adapted. I mean, obviously not bragging, but it was a really good paper that you guys did, and congrats for that. What I find interesting is the reference to the Chang et al. Paper when you have those different criteria for evaluation. And when you think of the evaluation and how to make it simple for people, I think defining the right criteria is definitely key. I love the fact that you use WhatsApp conversation to create your evaluation benchmark, and I think that's definitely a way forward. I mean, obviously you had access to it, so that was a great thing. And you also highlight, the ethics challenges when you deal with such a conversation message, and we'll come back also on the test we did on the chatbot for teenager reproductive health. That were similar challenges, but yeah, but I really like the fact that you address it, both quantitative and qualitative evaluation. Something that I found interesting is this paper, which is really about how can AI help people during red teaming sessions. And I found this one quite interesting because the goal is not to replace red teaming or testing of an AI model only by LLM, which is obviously very common right now, but it's maybe more to empower and to scale the efficiency of real red teaming people with AI. And I think this mixed integration of AI tools to better testing and evaluation is definitely a way to look at it and a way forward. Chatbot Arena, you're probably familiar with that. It is platform that is put online for users to compare. I mean, of course, huge scalability, and it's online and it's easy. But then after the question of the incentives that you provide to people, and then the most important question of who is going there, I guess it's key. And I think we're touching right now, especially with Africa, the discussion around benchmarking and evaluation on Africa, the key to find a way to segment and find the right annotators and contributors that belong to very specific segments, because it's not enough right now just to say, hey, we have collected the data set. We need to know who has been collecting this data and who has been annotating this data. And this very recent paper from the team at Google University of St. Louis is quite interesting as well, because they approach different way of improving the cultural, relevance of different models, and then using different benchmarks that exist to evaluate these. And it was quite interesting in the end, because they tested one method that is knowledge-based. So basically, just giving through a RAG, different data to a model. But the other one is connected to search, and so that you can have real-time information on the topic. And naturally, it gives a lot of depth in terms of, the information you can have of the web is very rich, but then, potentially reproducing some of the bias that you may have. And I definitely invite you guys to read this one. All right. And making a link to the work we do around, benchmarking and culturally relevant data sets, we did a lot of work specifically around the stereotypes. I mean, naturally, the potential harms that stereotypes can have. And again, some people that, at Google, but also, other, academics did a lot of work around the stereotypes. And just presenting this one because this one is one of the one we use as an inspiration and adapt it to the African context to do our Afri Stereo project. And without further ado, I'll let then my colleague DJ introduce Afri Stereo. Over to you, DJ.
Hello, thank you, Jan, for the introduction. So we're going to be talking about After Stereo, which involves stereotypes for a stereotype data set for bias evaluation. Next slide. So the first question we must ask ourselves is what exactly are we dealing with? And the objective of After Stereo is to put together a data set of stereotypes. And the reason is because most AI training and evaluation relies on data sets that come from the global north. And those are mostly in English and other dominant languages, and they don't represent African languages, cultures, and socioeconomic realities. So when we try to prompt these AI models about these things, it turns out that the understanding is not so well. And we also know that in NLP benchmarks, only 1 to 2% of data set come from Africa, which is a massive gap that skews how AI understands the content. So you can see in this diagram, like a figure of like where a few data sets come from, and you can see like the global south is pretty underrepresented. Yeah, next slide. And the thing is, these gaps do cause real world harm. So, across like important domains like healthcare, finance, and education, the implications could look like this. You could have in healthcare, you could have a tool that under prioritizes Black patient symptoms. In finance, you could have a credit scoring algorithm that just tends to like flags rural applicants as high risk based on some biased spending data. And in the education sector, you can have an AI grading system that is trained on foreign curricula and does not account for what African students' context-specific answers might look like. So these are all like instances where we have extreme real-world harm, and which is why we have Afri Stereo, where we aim to close the gap. So inspired by previous work done by Dave et al. Afri Stereo is an open source dataset built from real stereotypes gathered across various African countries. And our mission is to make AI bias evaluation truly global by including the beliefs, realities, and lived experiences of the African communities. Next step. So the methodology we use involves a few steps. So we start with data collection where we obtain open-ended surveys in English and French from people across a few countries in Africa, which report societal stereotypes. We translate everything into English for a unified model evaluation, and we use NLP models such as including LLMs to measure and analyze stereotype leakage. And once that's done, we have well, like this is our pilot phase, and we are like consistently refining our methodology for future surveys. And as Sareen talked about before, for collecting our surveys, we're using the LOOKA platform. So that's a Pan-African research tool for user insights. And how we're doing this is we're asking respondents to give us stereotypes linked to specific categories such as gender, age, profession, ethnic group, and religion. And we're distributing the survey through email, social media, and personal outreach. And we also have an additional section where surveyors can talk about any open-ended stereotypes that they might have heard of. Next slide. And once we have that, we get to the engineering side of things. So the data processing and cleaning happens. So let's take a look at the data. So the data looks something like this. And on taking a closer look, you see that it looks like you have multiple rows and each row looks something like this. So you have multiple entries that are comma separated, and these are like different stereotypes across different types. So like there's gender, there's ethnicity, etc. So the main issue here is that yeah. So the main challenge here is that it's very difficult to manually go through such a large volume of responses. And also, these responses are not uniform, and we need to bring this data into like a uniform form that we can work with. So to do this, we come up with a semi-automated data processing pipeline. So over here, we have multiple steps with the blue ones representing automated steps and the yellow ones representing human feedback. And because this process cannot be completely automated, we need human intervention. So we have the different steps here, and you can see like once we process the raw survey data, we use regular expressions to sort of extract stereotypes in the format below, and then we do a level of human feedback before we form attribute groups. After we form attribute groups, we annotate and edit them, and before we form the final stereotype table. So as you can see, there are multiple levels of human annotation in between, but forming attribute groups, like what does that mean? So next slide. So like let's discuss the need for grouping attributes. So consider this example where we have three different responses. So one is says men are smart, two says men are very smart, and three says men are intelligent. So so like here the three stereotypes will be captured as the identity term being men in all the cases, and the attribute term being either smart, very smart, or intelligent in the cases. And even though these sentences convey the exact same stereotype, unless we can find a way to group these attributes together, they would be counted as a separate one with a frequency of one each. But ideally, we would like to group them together so that we have a more accurate reflection of what stereotype is being reported how many times. So this is exactly why. So can we find a way of automatically grouping together attributes that convey the same thing? So for that, we come up with a grouping pipeline. And the idea is pretty simple. So we use the attribute terms, we use an open source embedding model and the cosine similarity scores to get the similarity matrix. And once we have that, we use a threshold to sort of group these initial attribute terms like this, and then we use a polarity detector model to sort of like differentiate the positive and negative adjectives. So what the initial attribute terms look like that, the final grouped attribute terms look more consistent. And once we do this, we do some touching up and we have our final stereotypes that look something like this. So this is the output of our first round of stereotype collection. And you can see there are identity terms and there are like group of attributes and also like the number of people across demographics who report a particular stereotype. So this is what a final output looks like. So let's discuss a few results. So we have gathered over 1,164 societal stereotypes from our initial data collection, and these come from the responses of over 107 respondents across three countries, including Senegal, Kenya, and Nigeria. These responses have been classified by various factors such as gender, religion, and ethnicity. And this word cloud shows a few frequently associated attributes. So we can see attributes such as money, love money, smart, emotional, powerful, strong. Those are like a lot of stereotypes that we keep seeing. We also look at like a few attribute groups that are repeated, and we see that a lot of interesting stereotypes involve attribute categories such as intelligent, smart, wise, strong, aggressive, violent, and emotional. So there are like certain characteristics that are being made about groups of people here, and that's an interesting thing that we observe. And we also obtain a few interesting regional stereotypes, which include ones like these, um, which are like reflected by quite a few people, which is why we have reported them here. And now we talk about the language model evaluation. So now that we've obtained, in the previous step, we've obtained a table of stereotypes, we set up an evaluation pipeline for measuring the tendencies of various language models to display these stereotypes. So for this, we use the framework put forward in this paper, which is called the stereotype anti-stereotype pair experiment. And the high level idea is given a set of identity terms and stereotypes, we construct what are called stereotypical sentences and anti-stereotypical sentences. And we use whatever model we're testing to obtain scores corresponding to each sentence representing the probability. And the idea is we measure the difference in these scores between the stereotype and anti-stereotype sentences, and we see whether that's significant difference. So I think it's best understood with an example. So consider the example where the identity term is men and the attribute term is strong. So we would form the stereotype sentence as men are strong, and we'd form the anti-stereotype sentence as men are weak. And the idea is that you would obtain a sort of like log probability corresponding to each sentence, the stereotype and the anti-stereotype sentence, and you calculate the bias score as being the difference between the two. Now, to understand these scores, when this bias score is highly positive, that means the model favors the stereotype. When the bias score is highly negative, that means the model favors the anti-stereotype. And either of those are bad. And when the score is close to zero, that means we cannot really conclude too much about the nature of the bias. And our results look something like this. So we have a few models. We have the bias preference ratio, which is the proportion of samples in which the model chooses the stereotype over the anti-stereotype. And you can see that a lot of these models tend to significantly choose the stereotype over the anti-stereotype. And the p-value, which sort of measures the significance of the obtained inference, tells us that in a lot of these cases, this difference is significant. And we also measure the significant bias axes to see that across axes like age, profession, gender, and religion, these models tend to show significant bias. And now I'm going to be passing it on to Oche to talk about data augmentation and annotation.
All right. Thank you very much, Dana. First, let me just next slide, please. So first, let me just start by outlining where our earlier methods fell short. First, we had the issue of scaling and coverage gaps because most of the stereotypes that we collected, they were kind of like very generalized and they leaned on global axes like gender, which were not particularly unique to Africa. So, but our initial goal was to, collect more regional and more ethnic stereotypes that actually reflect some of our realities, right? And second, we also have like evaluation challenges because the framework that we use as a stereotype and anti-stereotype framework has been shown to be sort of noisy in a sense. So we're trying to like expand into more frameworks like the natural language inference framework. And yeah, that is, more diverse and culturally grounded. Thank you. All right. So, how do we solve some of these problems that we faced in our data? So, one of the paths that we have taken is combining synthetic data generation with human annotators or human validation, because some research has shown that surveys alone tend to underrepresent minority identities. So, the goal of synthetic data generation here is to fill those gaps in a sense. But then we also realize that some of these models, they are not perfect. They often hallucinate. Sometimes they also exaggerate or, just put out false information. And that's why we have human annotators and human feedback in the loop. Yeah. Next slide, please. All right, so we experimented with different prompting strategies to actually generate our data set. So we use like the zero shot method and also the few shot prompting. So in the zero shot, you basically ask the model to sort of like generate a data set of negative stereotypes, and you don't really give it any example, you just give it a structure, right? And then we try to compare that with a few shot prompting by giving the model like 3 to 4 concrete examples of how we would want it to be. Maybe just deep diving into the communities, like let's say Fulani headers, Matatu drivers, or Wolof women, because in the initial data set, what we had were just women, but we weren't really specifying like the particular culture or yeah or ethnicity. Yeah, next slide, please. All right, so we tested various models for data augmentation because we're trying to like prompt these LLMs to be able to help us generate some of this. For example, wasn't giving us some of the typical stereotypes I wanted because it had like some guardrails or was very cautious. We tried Claude as well. Claude didn't give us any response. Gemini refused totally. And then the method that we used was we generated just like a bunch of very raw stereotypes from DeepSeek, and then we're able to use the few shot prompting to further generate more with mostly AI platform, which is a data augmentation platform as well. Yeah, next slide, please. All right, so these were some of the stereotypes that we're able to generate through our augmentation. Some of these are very offensive, but then these are some of the stereotypes that we need to actually have like a very robust evaluation result as well. So you can see that it's specifying, it's not just saying maybe women in general or men are strong, or it's specifying like the particular culture. Women are loud, argumentative. So this is the kind of structure that we are looking forward to for our next evaluation approach, which is the natural language inference approach. Yeah, next slide, please. So now here's some of the results that we achieved. So we expanded our data set from about 1,000 stereotypes to nearly 5,000. And we also have like improvements across the professions, ethnic and regional identity, and also the gender-based stereotypes. And we also had some key insights as well. And we primarily saw the best results with mostly AI. Yeah. Next slide, please. All right. So now the next steps that we're going forward with is trying to create maybe balanced anti-stereotypes so we can have like a more robust evaluation with the natural language inference. So we want to have the stereotypes, and then we want to have counter stereotypes as well. That will help the model to kind of like will help our evaluations with that as well. And then, yeah, we're also adopting the NLI based evaluation. And then we also have human annotators and human in the loop validation as well to sort of like rank offensiveness scores to validate if some of these stereotypes are actually real. All right, so now we'll just be taking a moment. If you have any questions, please just drop them in the chat. We'll be answering your questions right here in the chat as we move on to the next section. Thank you.
Fantastic. Thanks, Oche. I think you still go ahead with this one. I'm also, in interest of time, let's make sure we go maybe straight to the evaluation part and faster to the evaluation part, Oche and Elton, if that's fine.
Yeah, sure. All right, next slide, please. All right, so for our next project, which is Nakala, Nakala is an automatic speech recognition platform. So ASR, of course, has potential for Africa, but we're largely, it remains out of reach because of the many gaps that we have. And in our case, we focus on Wolof for our preliminary work because Wolof is a language that is spoken by 12 million people in Senegal. And despite its prominence, we have very little ASR resources for that language, especially in the aspect of healthcare. So this is very interesting for the work that we're currently doing right now on fine-tuning for maternal health as well. Next slide, please. So the previous, okay. So yeah, so we noticed some critical gaps like domain-specific models or social cultural context gaps where we don't have like very good performing models for code switching or regional accents. So we have to build very cultural specific models for healthcare applications as well. So next slide, please. All right, so for our data set creation and validation, to identify this, to address these gaps, we're able to collect about 250 relevant maternal and reproductive health terms, and then we're able to generate some contextual phrases from these terms, translated them into Wolof, and then validated them for cultural relevance, because this was what we wanted to use to, fine-tune the models that will be specific to healthcare in Wolof. So we had like a bunch of diverse speakers from different regions, different accents and variations, and then we're able to generate around 1 hour and 40 minutes of audio. And then we separated 120 samples for real world evaluations. Yeah. Next slide, please. Next slide, please. All right. So now I'll leave my colleague Etony to continue with the evaluation results.
Yeah, thank you, Oche. Yeah, just after collecting the data, um, can you previous slide, please? The evaluation. Yeah, thank you. So after collecting the data, we have to evaluate and to establish the benchmark, and we did different pre-processing when it comes to the audio and when it comes to the text. But the most important was just the normalization, just to unify the spelling because Wolof is one of the main languages that have different orthograph, and it was for us to normalize to have only a single vocabulary. So before fine-tuning, we evaluated different open source models on our data sets on 120 samples. We try to balance gender representation across data splits, and so we evaluate different models. As you can see the result in the table, and we found out that Aluali was Parmejum Wolof was doing better. So for the training, the training approach we apply LoRa, law adaptation for efficient fine tuning. So which only updates a small portion of parameters and keep the remaining frozen. So we applied different strategies for augmentation. As Oche mentioned, we had only 1 hour and 40 show. So we had to augment our data sets and we applied different techniques. We apply our speed perturbations. That is like helping just to slow down and to speed up uh, the audio clips. We augmented on noise level, which is like measures how um so we add like a background clinic noise to the data set just to help the model generalize very well. And after that we applied the pitch technique. So previous slide, please.
Sorry, Anthony, can we go straight to that part? For the interest of
Yeah,
time.
okay.
Sorry about that.
Okay, no problem. So the result we have, and we found like our internal evaluation, the WER, word error rate, has dropped significantly from 0.46 to 0.33. And after that, we conducted like a community based evaluation using that 120 samples, and that was inspired by the Microsoft as well. And then we compared the internal evaluation with the real world evaluation, and we found out that the model performance dropped on the real data. So, and the error rate rising about 35%, and for character error rate was rising about around 50%. So this highlighted the need for us to better adapt our model for robustness. So what was the key findings for this study? The first one was the normalization, because Wolof often exhibit a consistent spelling due to original or individual variations. So it was essential to preserve both semantic accuracy and the cultural relevance. And also, another thing was to evaluate on half related words, in which we came up with a special metrics that just help us to measure how our model is learning these half related keywords. So for the next step, we are going to extend the keyword list. We are going to extend our data sets. Um, So we are going to include recording from diverse speakers to assure that the model it generalized very well. So another thing which will be to it will be to build that population-specific half lexicon. So we are going to extend the current keyword set, taking into account the education, region, and the half context, and leveraging recent segmentation work from YUX projects, like the one we did with the Get Foundation. Finally, we have a tool that's helping researcher to transcribe, and we are aiming to improve that tool yet. So it has different features, but the main feature now is just to transcribe audio clip in the Wolof, and we are going further to do it in different other languages such as Hausa and maybe Swahili too.
Yep. Thanks, Oche. Thanks, team. I'll go skip this part and for the interest of time, maybe come back in the discussion. And then I'll hand it over then to Oluchi to very quickly then talk about product evaluations. Over to you, Oluchi.
Thanks, Jan. So just very quickly, within the UX of AI and the human AI interaction space, we've been doing a lot of reading of the literature, and I'll just be presenting a few papers. What we found is that a lot of the literature has explored how established usability and UX methodologies, UX evaluation methodologies can be adapted to AI-enabled products or environments. So for example, this paper by Stravula and Tao analyzed 46 frameworks across adaptive systems, ubiquitous computing, and intelligent environments. So a key takeaway from this review that was done was that while there's a lot of frameworks out there that identify important UX concepts, a lot of these frameworks still remain purely conceptual and just really defines what should be measured and not necessarily going into details on how to measure it. So a lot of the challenges that stem from this is just, challenges related to assessing adaptive system behavior, whether it's effective, efficient, and satisfying, as well as evaluating products and environments holistically rather than just their individual components. And because these AI products and systems are quite complex, evaluation needs to go beyond lab studies and just go into real world context and account for parameters like trust, adoption, privacy, safety, user attention, etc. So typical UX methods like the simulation tools, living labs tools, etc. Can evaluate AI products, but the UX of AI field still needs to go beyond these theoretical evaluation metrics and go into practical frameworks that connect high-level UX concepts with high-level concrete metrics for evaluating AI products. And then Jan, maybe we could skip this slide and then go on to the next slide. Next slide, please. Oh, sorry, previous slide. So just quickly, while some research focuses on adapting or adopting metrics for AI, other work warns against relying too much on them. So there's a perspective paper that shows that chasing metric scores alone when evaluating AI products can cause real harm. So for example, recommendation systems that push people towards radical content, or essay grading systems that reward jargon just because it looks complex. And so to avoid these pitfalls, the author suggests some steps to use when evaluating or when using metrics for evaluation. And number one is just using a myriad of metrics rather than just one, bringing in independent audits, combining metrics with qualitative methods like interviews or observation, and involving a wide range of stakeholders, especially those most affected by the system. And so along the lines of moving beyond metrics, there have been papers that propose design guidelines for AI products across different stages. So for example, the work by Amershi et al. From Microsoft developed 18 guidelines for human AI interactions. Okay. And then just to round up, when we talk about factors, metrics, and guidelines for evaluating AI products, it's really important to remember that they cannot be applied in a vacuum, so they need to be contextualized. So what works in one setting may not capture the realities of another setting. And so building on this and also drawing from our work, evaluating products in the African context. So in addition to the AfriStereo dataset for evaluating models that my colleague has presented, we've also developed and brainstormed on some practical guidelines for designing and evaluating AI systems within the African context. So first, there are things to look out for. So can the system handle code switching? Does it run on low bandwidth or low end devices? Does it respect local cultural references? Does it work fairly across literacy levels and rural urban divides? And then beyond that, there are also other things to take into considerations, like are we testing with inclusive groups, not just the urban elites? Are we making sure the system is explainable and trustworthy for non-technical users? What are the ethical stakes, etc.? And then finally, when it comes to methods, there are some that work particularly well in the African context. So for example, methods that include participatory evaluation that involve the end users, also stress tests that check performance under conditions like low internet, multilingual input or communal use, and also community audits that allow for local oversight and accountability. And so on that note, on some methodology, I'll pass it on to my colleague, Elizabeth, that will give some case studies on what we've done in the past.
Okay, everyone, next slide, please. Oh. Amian, is it on the next slide? I'm still seeing all of these slides.
Yeah, really supposed to be on the next slides. Can you guys see the next slide?
Yeah.
Yeah, it's fine. I'll just, yeah, I guess it's my internet. I'll just present with that. So for this case study, I'm mostly presenting one case study, but case study of the project we worked with the Google team, like last year and 2 years ago and last year, start of last year. And the main goal of the project was to really understand how to make sense of like Africans' digital behavior at scale. So this, for the Google team, this study was kind of foundational for them. So they were exploring some digital behaviors of 1,000 people across like Kenya, Nigeria, Ghana, and South Africa to understand, you know, some of their underlying motivations. And that's like 250 people in each country. And the interesting part of this is like, if you want to understand some motivations, at the end of the day, beyond like surveys, like beyond having questions where you give people options, you need to have some like qualitative questions or qualitative questions that would be useful to help you make sense of this. Right, next slide, please. Yeah. Okay. And for the methodology, right, the approach to data collection, well, this method is not solely from us, it's mainly from the Google team, but we worked with them to like contextualize it for the 4 countries who were doing research. But the survey data collection ran like a what diary study. So we had different WhatsApp groups. We had people on the LOOKA team collecting data, working with like surveyors that were pinging people at different points of the day to fill out the survey. And we also had, and they fill this data out 5 times a day over 5 days. And the questionnaire also had like 2 open-ended questions that are asking them those questions that they really have to explain, right? I also just point out here, the participants were also incentivized because, as you can imagine, like responding to a survey 5 times a day over 5 days, it requires a lot of effort and to keep their attention. And one of the reasons we used WhatsApp to like, you know, keep following up with people as well and asking them to fill the form is even something we noticed then, like, you know, some people were not able to fill the form at the right time, maybe internet connectivity, maybe electricity issue and things like that. But at the end of the study, we had collected about 25,000 responses from like 4 different countries. We had a total of 22 questions. 2 of them were open-ended. So as a result, we had like 50,000 open-ended entries to analyze. To make sense of this, right, I just wanted to say that this was not necessarily a study on on AI specifically, but it was a study on like understanding digital behavior. So to make sense of this, we analyzed to analyze the open-ended questions. The Google team already has some categories that they would use as an entry point to like group the open-ended questions into like into themes so that we can cross-analyze them against the other questions that add options. But we also looked at the data and saw, because this was the first time they were doing the study in the African context, trying to see if there were other themes that emerged before and can be included in the categories. So that was more like a manual look through of the data, or just like breezing through the data. And then we used an AI tool to analyze it. The first phase was mostly kind of like duct tape, but like eventually by the second phase of the study, we kind of used Vertex AI to code the responses into things. And one of the reflections from this is like the methodology is best suited for a study where you kind of like have a pointed question you want to answer. So the next slide. The next slide is really talking about, so while we're talking about this and like, you know, from the literature review Oluchi have described, we're trying to think, how can this be useful in the context of evaluating AI tools? Because at the end of the day, this methodology is interesting because it has, it has scale, like you can scale the number of responses, and you still have you're still able to ask some qualitative questions. The first thing we mentioned here is like to be very specific about the area of exploration. And something that's interesting, and a conversation we had yesterday with Jan and the rest of the team, was that in a world where a lot of people are growing more accustomed to sharing everything they want to share on chatbots, what's the value of this methodology? But the value of this methodology is that you can, while people may be sharing things about maybe chatting with their chatbot, telling the chatbot how their day went, we can ask more pointed questions that they may have not thought of, and ask them to answer these questions about their use or about their perceptions, and be able to generate more specific answers from them beyond what they would naturally share. And I mean, the depth at scale, and this methodology shines in balancing depth with scale. Interviews, small scale interviews, while they are also in depth, they don't have it's not very feasible to interview 35,000 people within the time we did this study. And yeah, it's also a good approach for like measuring emergent behaviors that can be relevant either for like benchmarking cultural relevance, like, you know, making sure that the study is representative across different regions, different parts, different socioeconomic classes, because we were also specific about the different groups of people we want to target, and because there were also LOOKA surveyors following up with people and recruiting people, not just online, but also in person, helped us like bring together a diverse group of people. We also have the second use case where it can be relevant, which is for product evaluation, where you can really collect responses to people, like even about things like trust, or ask specific questions, and yeah, tests tools. Or yeah, that's it, I think. Jan?
Fantastic. Thanks a lot, Ellie. And I'm very conscious of time, so probably want to skip this last use case that we had, but I'm just going to say like one word about it. It's on the methodology. So it was mixing red teaming to be able to assess, you know, if a chatbot for reproductive health was safe and ready to be, you know, launched at more scale, but also mixing that with co-creation, so that you not only evaluate, but you ask the user to give recommendation on the spot and improve the chatbot experience with them on the spot. So we'll share the slide afterwards, so don't worry. But you know what's interesting about this chatbot for health? It was based on the script of a TV show, which I guess is the core of the experience that was proposed in this chatbot. It was, you know, you can talk not only with one interlocutor or the chatbot, but you can talk with 4 personas who are actually the main characters of the TV show, which is definitely one of the interesting learning we had down the road. And I'll go straight to the learnings. I'm sorry. Is that, you know, having different persona is something that is very valuable in terms of experience, but it was a bit confusing for the users, because when they ask a specific question on XYZ topic, you will have automatically this persona who is the most suited for that topic that will come in. And so it's all about, if you want to personify your different responses, it's all about you communicate that to the users. But basically, the mix of red teaming and co-creation was super valuable, because you not only ask and evaluate, but you get specific feedback and ideas. What was very important when you do such a thing is not like a user test when you can just come and ask specific feedback, but you can have a mix of different methodologies. One are kind of closed-ended, asking specific task submission like you would do in a traditional user testing. But then after, you can have also a very open-ended scenario, like, hey, just imagine you are in this situation, what would you do? And this is the beauty with generative AI, is that people can imagine so many questions they may have. And that links to the second thing, is that it's important to do this kind of methodology when you have people coming back, because a lot of the use case of generative AI is not something that is a task that you do right now that you think of. You need to take time to really leave experience, and then after think about the question you may ask to such a chatbot. And so having session where every week we will see people for different group, but we'll see them every week, was super valuable, because not only they had the time to think about different things to ask the chatbots, but they also have the time, to reflect together and engage together and so on. So I'll share also some learnings about, AI chatbot for health, but maybe that's another question. But one key element here is always, the segmentation, like who is it addressed to? And when we deal with evaluation, I think one of the key thing is on that. The second element that is critical when we talk about evaluation is that what is the balance between having access to all the conversation logs and user data for the improvement versus the fact that is privacy breach, and I think this is still something that the community is still grappling with. Closing on, if you have to just remember a few things of our presentation, and sorry, it was a lot of content and it was fast, but I mean, of course, we know you understand everything we share is to show that performance is not enough. We really believe that product adoption will really grow when we'll have culturally grounded AI models and product. The second thing that we really believe on is that at some point, at every step of the way, actually, you need to speak to real humans. And this is where social science, HCI people, UX people are really useful. So big learnings, and maybe the learnings we often share that as how might we, in the design field. For us is that how can you scale, the creation of data sets that are culturally grounded? How can you make sure that the contribution of people are, kind of, accessible, in remote areas or people who are less connected? And this is probably where tools like LOOKA that touch people who are not connected could be useful. How do we give back to communities? And how do we make it easy or mandatory to test your model on the cultural relevance before going to the next phase? And I say mandatory because maybe at some point we'll need regulation to be able to pass different thresholds, or maybe we need investors to look at what is the framework and things you need to pass before going to the next level. On the product evaluation, we really encourage the community around HCI and UX to really think about how we adapt all the things that we've been doing in the past to AI products, but to AI product on the continent, because the usage is going to be very different. And so we need to adapt all the toolbox that we've been using for several years. Again, how do we make it easy / maybe mandatory for people to test their product? Because a lot of AI chatbots or solution will not actually be built by AI engineer, and maybe it's people just taking something online. So how do we make it easy for them to be able to test the cultural relevance of their product? And last one, as we look, at this capability that AI system will soon have to improve themselves based on the data they collect, how do we make sure that they don't amplify potential harms, biases? And when they learn on their existing data, how do they have access to culturally grounded data? But yeah, just leaving you guys with these questions. We don't have all the answers, but thanks so much. Sorry, we went a bit over time, but thanks so much for all of that. And we'll share this presentation in the slide, obviously, and happy to get in touch with people interested by the same topics. Thank you.
So exciting. This was wonderful presentation, team, and we are so grateful that you shared all of your work with us. I mean, we really enjoyed like from end to end. So okay, we are over time, so it's okay. So we can still stay. I wonder if someone, I mean, if there is any question that someone, if you have any question that you want to ask, you can just come unmute and ask your question. Otherwise, we are so grateful that DJ, Oche, Etoni, you guys were able to answer most of our questions on the chat. So I wonder if anyone has like any comment or overall question. Okay, cool. So Jan, and just want to say thank you very much. This was quite exciting presentation, you and the entire team. I think I just had like one quick comment of like, I think we'll still reach out for more engagements with you in terms of because would love to learn a lot from you, and I think this time we'll make it in a way that we have different component of the work that you're doing presented on different calls so that we, talk more about, for instance, if it is model evaluation, then we focus on it and then we learn much more, and then we come on another session for product evaluation, and I think they are all interesting, and for me, I learned a lot. And yeah, thank you very much. We'd like to keep us updated on the progress of your work, including the work that will be going on Afri Stereo, everything. Just keep us posted, and yeah, we'll welcome you back to come and do another presentation. At this point, we'll just end the call, and thank you very, very much again, everybody.
Thank you very much, team. Thanks, everyone, and kudos to the YUX team.